When Japanese soldiers surrounded a lone American fighter in China, they thought they'd captured a plane. What they found instead was the blueprint of their own defeat. On January 16, 1945, at a remote airfield near Suchin in eastern China, a group of Japanese soldiers surrounded a single American fighter that had just touched down. Its pilot, First Lieutenant Oliver Strawbridge, was quickly taken prisoner. Yet it wasn't the man they captured that would send shockwaves through the Japanese military. It was the machine he flew. The aircraft, a P-51 Mustang nicknamed Evelina, stood intact on Japanese-controlled soil. For Japan's Army Air Force, it was nothing short of an intelligence miracle. They had in their hands the very aircraft that had been dominating their skies, the fighter that had steadily dismantled their air superiority across the Pacific. Since late 1943, Japanese aviators had been falling to this new American warplane in ever-increasing numbers. Time after time, dogfights ended with the same outcome. The Mustang reigned supreme. It was faster, climbed higher, dove harder, and carried heavier firepower. It was not merely an aircraft. It was a symbol of an industrial machine Japan could not match. Now, with Evelina intact and grounded before them, Japanese engineers saw their chance to uncover its secrets. Somewhere within its frame, they hoped, might lie a flaw, a single weakness that could turn the tide of air combat back in their favor. The Japanese understood well the power of studying captured technology. Just 3 years earlier, the Americans had done the same when they recovered a largely intact A-6M0 fighter on Akutan Island after the Battle of Midway. That single captured Zero had exposed critical weaknesses, light armor, poor dive performance, and vulnerable fuel tanks. Revelations that led directly to new Allied tactics that erased Japan's early air dominance. Now, in 1945, it was Japan's turn to examine the enemy's prized weapon. Within days, Evelina was repaired and ready for testing. Mechanics patched up minor damage and repainted the insignia. Red Hinamaru circles hastily replaced the American stars and bars. Otherwise, the aircraft was left untouched. Its polished silver skin, red dragon-mouth nose art, and kill markings along the fuselage remained, silent reminders of the pilots who had fallen to it. The mission to test fly Evelina was given to one of Japan's finest, Captain Yasuhiko Kuroe, a veteran ace credited with 30 victories. If anyone could understand the Mustang's capabilities, it was him. When Kuro climbed into the cockpit at the Japanese-held airstrip, the difference was immediate. As he started the engine, a deep, steady growl filled the air. The Packard-built Rolls-Royce Merlin came to life, not with the rattling vibration he was used to, but with perfect smoothness. There was no hesitation, no sputter, no uneven rumble, just precision. Japanese aircraft engines, even brand new, were notorious for their inconsistencies. Wartime shortages had forced factories to cut corners. Inferior metals, loose tolerances, and rushed assembly were unavoidable realities. But the Merlin engine felt like a completely different species of machine. Then Kuro noticed something that left him genuinely stunned. There were no oil leaks. Every Japanese engine he'd flown, from the nimble Ki-43 to the powerful Ki-84, leaked constantly. It was so normal that mechanics carried rags as standard tools. Oil leaks weren't just messy. They were dangerous, a fire risk and a constant maintenance nightmare. But Evelina's engine was bone dry. That one detail told him everything. It spoke to engineering precision, to manufacturing tolerances Japan's factories simply could not replicate. As Kuro lifted the Mustang off the runway, he began methodically pushing the aircraft to its limits. The controls were fluid, balanced, and obedient. In a high-speed dive, the Mustang remained perfectly stable. No vibration, no wing flutter, no loss of control. Japanese fighters often buckled or shuddered during steep dives. The Mustang, by contrast, seemed built for it. It was faster than anything he had ever flown. When Kuro returned to base and stepped out of the cockpit, a crowd had already gathered, engineers, officers, and test pilots eager for his verdict. His response was short but devastating. "It flies better than anything we have." For Japan's top brass, it was a sobering statement. Kuro's report went beyond praise for the aircraft's agility or speed. He described a complete system, a war machine that reflected an entirely different philosophy of design and production. The Mustang's radio system was flawless, a revelation to a pilot used to unreliable communication equipment. Japanese radios were so prone to failure that many aces ignored them entirely, relying on hand signals during combat. But American pilots could coordinate effortlessly, executing complex group maneuvers and receiving real-time intelligence while in flight. It was this ability, not just speed or power, that made the P-51 a weapon of teamwork. Even more impressive was the navigation system. The directional radio beacon allowed a pilot to find his base even in storms, or when wounded and disoriented. Many Japanese pilots died not from enemy fire, but from running out of fuel after getting lost. The Mustang's instruments turned what was once a death sentence into a safe return home. Every switch, dial, and cable inside Evelina reflected one idea: a pilot's life was worth preserving. In the American system, aircraft were replaceable. Pilots were not. Trained aviators represented a human investment. Their survival mattered. Japan's design philosophy was the opposite. Its fighters, like the famous Zero, were masterpieces of maneuverability, but paper-thin, sacrificing armor and durability for agility. A single bullet could end both machine and man. The Mustang, however, protected its pilot with armored glass and a reinforced steel seat. It wasn't just fast, and it was survivable. When Kuro compared Evelina with other captured aircraft, such as a German Focke-Wulf 190A, he noted that while the German fighter was slightly faster in a straight line, the Mustang outperformed it in dives, stability, and fuel economy. It was the complete package, balanced, efficient, and designed for sustained warfare. Fuel testing revealed something even more ominous. The Mustang's range was astounding. Engineers calculated that with its fuel efficiency, it could easily reach the Japanese home islands from Allied bases as far away as Iwo Jima. Months later, that exact scenario would come true. P-51s escorting B-29 bombers over Tokyo. Another Japanese ace, Captain Yohei Hinoki, was ordered to fly Evelina and train others in its operation. His connection to the Mustang was personal. In 1943, he had shot one down, and soon after was shot down by another, losing his leg. Now fitted with an artificial limb, he climbed into Evelina's cockpit with both professional curiosity and deep respect. His impressions echoed Kuro's astonishment. The seat was spacious, the controls intuitive. Even with his prosthetic leg, he could manage the pedals with ease, something impossible in the cramped cockpits of Japanese fighters. The visibility through the canopy was superb, protected by thick, crystal-clear bulletproof glass. He marveled at the layers of armor surrounding the pilot's seat, protection he had never seen before. For Hinoki, who had nearly died in an unarmored cockpit, it was a revelation. He described the oxygen system, the automatic radiator shutter, the reliability of every gauge, each feature demonstrating that American engineers had designed for endurance, safety, and mass replication. His conclusion was simple and humbling. It was better equipped than any Japanese aircraft I had ever seen. While pilots tested Evelina in the air, teams of engineers examined it on the ground. They disassembled the Packard Merlin, measured every component, and documented its tolerances. The results were staggering. Every single part, from piston rings to bearings, showed a level of precision Japan's factories couldn't replicate on a large scale. The Americans had achieved the unthinkable. They had turned high-performance engineering into a mass-produced science. The numbers were damning. Packard's factories alone had produced more than 55,000 Merlin engines, nearly as many as Japan's total aircraft engine output for the entire war. A single American engine type almost equaled the industrial output of an entire empire. Even worse, Japan's quality was declining by 1945. Factories were running out of metals, tolerances were widening, and substitutes replaced key alloys. Meanwhile, the Mustang's engine in Evelina showed zero compromise. Perfect machining, flawless finish, enduring power. The contrast revealed a truth more devastating than any bomb. Japan wasn't just losing battles, it was losing the ability to build. The P-51 Mustang that had fallen into Japanese hands was moved to a small airfield outside Tokyo, under strict secrecy. Only a handful of engineers and pilots were allowed near it. They referred to it simply as the American fighter, though, in hushed tones, they admitted it was unlike anything Japan had ever built. As the transport crew removed the panels and examined the fuselage, A silence hung over the hangar. Every line of the Mustang's frame, every rivet, spoke of a manufacturing precision that bordered on perfection. The engineers were trained men, some of the best in the empire. They had built the Mitsubishi Zero, a fighter that once ruled the skies of the Pacific. Yet here in front of them was a machine from another world, stronger, sleeker, and somehow built faster than they could ever imagine. One of the first men to inspect the Mustang's airframe was Lieutenant Colonel Masao Koga, an aeronautical engineer who had worked on several Japanese prototypes. He ran his hand along the aluminum skin and noticed how seamlessly it curved. There were no gaps, no crude welding marks, no uneven joints. Even the rivets were flush, creating a smooth surface that reduced drag. Japan's fighters, even their best ones, bore the scars of manual labor, small imperfections from hand-hammered parts and uneven machining. Koga noted this in his journal. Every part fits as though born from the same mold. It is as if the machine was not assembled, but grown. The team dismantled sections of the plane for closer study. They weighed the wings, examined the spars, and inspected the radiator system beneath the fuselage. The discovery of the laminar flow wing design astonished them. Instead of the thick, curved profiles typical of Japanese aircraft, the Mustang's wing was thin and sharply tapered, designed to slice through the air with minimal resistance. This innovation, they realized, was not just aerodynamic genius. It was industrial audacity. It required an exactness in production that only a powerful factory system could achieve. Then came the moment that truly stunned them: the engine. When the cowling was removed, the engineers stood in awe. Inside sat the Rolls-Royce Merlin engine, built under license by Packard in the United States. Its complex supercharger system, fuel injection precision, and durable construction represented an entire industrial world Japan did not possess. They took apart one of the pistons and studied the machining under magnification. The surface was mirror smooth with tolerances so tight that the part could slide in and out of the cylinder without resistance or wobble. Koga turned to his assistant and said quietly, "To build even one of these engines here would take months. To build thousands is unthinkable." For days, teams of mechanics worked to understand the Mustang's secret. They compared it with captured wrecks of American planes, the P-40 Warhawk, the P-38 Lightning, but none came close to the sophistication of the Mustang. The Merlin engine's intercooler and supercharger stages allowed it to perform at altitudes where Japanese aircraft simply gasped for air. One pilot, Captain Haruo Sato, was chosen to test fly the repaired Mustang. After several weeks of preparation, the day came. The plane, painted hastily with Japanese markings, sat gleaming on the runway. Sato climbed into the cockpit and scanned the array of gauges and switches, many labeled in English. He took a deep breath and pushed the throttle forward. The sound that erupted from the Merlin engine was unlike any Japanese aircraft. It was deep and confident, a steady roar that carried both strength and control. As the plane accelerated down the runway, Sato felt the sheer smoothness of its power. There was no vibration, no hesitation, just seamless thrust. Moments later, the Mustang was airborne. Observers on the ground watched in stunned silence as the captured American fighter soared over the airfield. Its climb rate, its roll response, its acceleration, all seemed almost unreal. Sato later reported that the Mustang could outclimb, outdive, and outlast nearly everything Japan had. It handled with precision even at high speed, where most Japanese planes began to tremble or lose control. When he landed, Sato removed his helmet and sat quietly for a long moment. Then he simply said, "We cannot match this." The engineers recorded his report in detail. The Mustang, they concluded, was not just a triumph of design. It was a product of an industrial ecosystem beyond Japan's reach. American factories, powered by automated machinery and mass production, could create thousands of identical components with microscopic precision. Japan, by contrast, still relied heavily on craftsmanship. Skilled, yes, but slow and inconsistent. Each Zero or Ki-84 built in Japan carried small differences, subtle flaws that added up in combat. The Mustang, on the other hand, was the same, no matter where it was built, Detroit, Dallas, or California, because it was born of machines that replicated perfection. As the reports circulated through Japan's Air Ministry, some officers refused to believe them. The pride of the Imperial Army Air Service could not accept that America's strength lay not in pilots or bravery, but in factories and assembly lines. Yet the data was irrefutable. Every aspect of the P-51 reflected industrial precision, interchangeable parts, modular systems, efficient logistics. One engineer described it bluntly. "This is not a plane built by men. It is built by machines that serve men." That realization spread like a quiet shockwave through Japan's technical community. The captured Mustang had become a mirror, reflecting not only the limits of Japan's aircraft design, but the deeper reality of a nation outproduced. The Empire could train skilled pilots, design agile planes, and fight with courage, but it could not match the relentless machinery of American industry. In secret meetings, engineers debated how Japan could respond. Some proposed copying the Mustang's design. Others, more realistic, said it was impossible. Without the massive steel presses, precision lathes, and automated assembly lines that filled American factories, a true reproduction could never be achieved, and time was running out. By mid-1945, American bombers darkened Japan's skies almost daily. The P-51 Mustangs now escorted B-29s deep into Japanese territory, protecting them as they incinerated the cities below. Ironically, the very plane Japan had studied and admired was now the symbol of its destruction. A machine whose secret lay not in its wings or guns, but in the industrial power that had created it. To the Japanese who had once touched the captured Mustang in awe, the lesson was clear. The war in the air was no longer about heroism or tactics. It was about who could build faster, better, and stronger. And in that contest, Japan was already defeated. But what began as curiosity soon turned into quiet despair. When the engineers presented their final report to Tokyo headquarters, the findings read less like a technical document and more like an obituary. The P-51 Mustang was not simply a superior fighter. It was proof that Japan's dream of parity with the United States had been an illusion all along. Every component told the same story. The electrical wiring used standardized connectors that could be swapped instantly in the field. The landing gear folded with hydraulic precision that Japanese mechanics struggled to reproduce even on the ground. And the Mustang's canopy, made of crystal-clear plexiglass, had been molded in factories turning out thousands every week. Where Japan's industry still shaped glass by hand, America shaped it by the ton. Colonel Koga summarized it in one devastating line: "They fight with factories. We fight with hands." In truth, the Mustang's secret was not hidden within the aircraft at all. It was hidden across the oceans, inside the American industrial web that produced it. By 1944, the United States had transformed its civilian economy into a war engine. Detroit's automobile plants no longer built cars, they built power. Ford's Willow Run plant alone turned out one B-24 bomber every 63 minutes. At North American Aviation, workers assembled Mustangs along mechanized lines that looked more like magic than manufacturing to Japanese observers. Each rivet gun, each jig, each measurement was controlled by precision tools that delivered identical results across thousands of airframes. This was mass precision, a concept nearly alien to Japan's wartime production. While Japanese factories relied on artisans, America relied on repeatability. A part made in California would fit perfectly into an aircraft built in Kansas without adjustment. That was the true miracle the Japanese pilots had witnessed. The Mustang embodied the idea that technology was only as strong as the system that built it. Japan could design brilliant aircraft like the Ki-84 Hayate or the Shinden-Kai, but without the infrastructure to mass-produce engines and parts, those designs remained few, fragile, and inconsistent. America's advantage lay not in genius alone, but in scale. As the analysis circulated, senior officers tried to keep morale intact. Official memos spoke of learning from the enemy's methods and preparing a new industrial approach. But deep down, the engineers knew the truth. By the time Japan could replicate such production, the war would already be lost. When American forces advanced across the Pacific in 1945, the P-51 became a symbol of inevitability. It escorted bombers over Formosa, Okinawa, and finally the Japanese home islands. The pilots who once studied the captured Mustang now watched hundreds of them crossing the sky in formation, their silver wings gleaming in the sunlight. Some whispered bitterly that the same sound they had admired months before, the steady hum of the Merlin engine, was now the sound of approaching death. Factories that had once built Zeros were now piles of rubble. Machinists who had marveled at the Mustang's polished pistons now worked with scavenged tools and recycled aluminum. Every attempt to produce high-altitude interceptors faltered from shortages of steel, fuel, or precision bearings. Even Japan's best minds could not build machines without materials. The Mustang, in contrast, kept coming, fresh, uniform, unrelenting. Every time a new squadron arrived, it looked exactly like the last. That uniformity, once merely technical, now carried psychological weight, an empire of machines fighting with perfect coordination against a nation held together by human endurance. By the summer of 1945, the skies over Japan belonged entirely to the Americans. B-29 bombers rained destruction upon every major city. When they flew without opposition, the P-51s prowled below, hunting anything that moved, trains, trucks, even lone soldiers. For the Japanese pilots who still took to the air, it was like charging into a storm with paper wings. Their own planes, light and agile at low altitude, became unstable in high-speed dives. Engines overheated, weapons jammed, fuel ran dry before they even reached the target. In contrast, the Mustangs climbed effortlessly through thin air, fought for hours, and returned home without a scratch. On one of the last days before surrender, an aging Japanese test pilot who had helped study the captured Mustang stood on the ruins of his airfield. Above him, he saw a formation of the same aircraft streaking toward the horizon. He is said to have remarked quietly, "The war was not lost in the skies. It was lost in the factories." When Japan surrendered in August 1945, Allied occupation forces found the remains of the captured P-51 still stored in a hangar outside Tokyo, its aluminum skin weathered, its engine silent. American officers who inspected it were surprised to learn that it had been studied so thoroughly. For the Japanese engineers, however, the aircraft had long since ceased to be a trophy. It had become a lesson. In the years after the war, many of those same engineers helped rebuild Japan's industrial base. They applied what they had learned from the Mustang, not in war but in peace. Precision tooling, standardized production, interchangeable parts. These principles would eventually power Japan's post-war miracle. Factories that once made fighters began producing cars, electronics, and machines of astonishing quality. The same men who once bowed before a captured enemy, aircraft now led an industrial rebirth that shocked the world in an entirely different way. The P-51 Mustang remains one of history's most celebrated fighters, but its true legacy lies beyond the battlefield. It revealed that wars of the modern age are not won by bravery alone, nor even by strategy, but by the invisible armies of engineers, machinists, and assembly line workers who turn blueprints into reality. When Japanese pilots first touched the captured Mustang, they saw a perfect machine. What they could not yet see was the vast network of power plants, steel mills, and factories behind it, an industrial organism capable of building freedom itself into metal. That was America's real secret, not the Mustang's wings, nor its engine, but the system that created both, a system that turned invention into abundance, and abundance into victory. And so, in the quiet aftermath of war, the lessons of that single captured plane echoed far beyond its broken fuselage. It taught the world that the future would belong to those who could not only imagine great machines, but build them by the thousands. The captured P-51 Mustang was more than a machine. It was a mirror reflecting the truth of an era. From that moment, the world understood that power in war and peace would belong to those who mastered production, precision, and progress. If you enjoyed uncovering this forgotten story from the final days of World War II, don't forget to explore our next documentary, where another secret of the war's machines waits to be revealed.